Welcome to Sriram Physics Pilot. In the video, we will see 9th standard Science Physics 5th unit Magnetism and Electromagnetism. And the answer in brief and answer in detail. Answer in brief. First question. State Fleming's left-hand rule. It states that while stretching the three fingers of the left hand in a perpendicular manner with each other, if the direction of the current is denoted by the middle finger of the left hand and the second finger is for the direction of the magnetic field, then the thumb of the left hand denotes the direction of the force or movement of the conductor. Second question. Define magnetic flux density. The number of magnetic field lines crossing unit area kept normal to the direction of field lines is called magnetic flux density. Its unit is Weber per meter square. Next question. List the main parts of an electric motor. The main parts of an electric motor are shaft, primary and secondary windings, ball bearings, armature, stator, commutator, brushes and terminals. Question number 4. Draw and label the diagram of an AC generator. Look at the diagram. So the parts. Here N and S, it indicates permanent magnet. A, B, C, D, it's a rectangular coil or armature. S1, S2, slip rings. B1, B2, carbon brushes. State the advantages of an AC over DC. The voltage of AC can be varied easily using a device called a transformer. The AC can be carried over a long distances using step-up transformers. The loss of energy while distributing current in the form of AC is negligible. Direct current cannot be transmitted as such. The AC can be easily converted into DC. Generating AC is easier than DC. The AC can produce electromagnetic induction, which is useful in several ways. Question number 6. Differentiate step-up and step-down transformer. So step-up transformer, device used to rise the electric voltage, that is V of S is greater than V of P. In step-down transformer, device used to reduce the voltage, that is V of S less than V of P. Second difference, step-up transformer has more turns on its secondary winding in comparison to the primary one. In step-down transformer, it has fewer turns on the secondary winding. Third point, step-up transformer. It is used to start the electrical motor and step up the windings. So third point in step-down transformer, it is used to balance the ratio of voltage and current on the primary and the secondary windings. Fourth point, step-up transformer. It takes a lot of voltage to initially start the motor turning. It increases the voltage but decreases the current. Fourth point, step-down transformer. The secondary windings have fewer turns, which mean low voltage and higher current, why it is the opposite in the case of the primary winding. Fifth point, stepper transformer. It is found in a television and in power stations. Step-down transformer. Fifth point. It is found in laptops and phone chargers. Some question. A portable radio has a built-in transformer so that it can work from the mains instead of batteries. Is this a step-up or step-down transformer? Give reason. Answer. A step-down transformer is used in a portable radio in order to reduce the voltage. Question number 8. State Faraday's laws of electromagnetic induction. Answer. First law. Whenever there is a change in magnetic flux linked to a coil, an electric current is induced. The induced potential difference lasts so long as there is a change in the magnetic flux linked with the coil. Is directly proportional to the rate of change of magnetic flux linked with the coil. Next, answer in detail. First question. Explain the principle, construction and working of a DC motor. Principle. An electric motor is a device which converts electrical energy into mechanical energy. The diagram is given. Construction. An electric motor consists of the following main parts. Armature. It is a rectangular coil ABCD having a large number of turns of this insulated copper wire wound over a soft iron core. The armature is placed between the poles of the field magnet and it can be rotated about an axis perpendicular to the magnetic field lines. Split rings, also called as commutators. It consists of a cylindrical metal ring split into two halves, S1 and S2. As the coil rotates, the split rings also rotate about the same axis of rotation. The function of the split ring is to reverse the direction of current in the coil after every half rotation. Carbon brushes. Two graphite or flexible metal rods maintain a sliding contact with split rings S1 and S2 alternately. Battery. A battery of few cells is connected to the brushes. The current from the battery flows to the armature coil through the brushes and the split rings. Working. A simple coil is placed inside two poles of a magnet. In segment AB, the direction of the current is towards B, whereas in the conductor segment CD, the direction is opposite. As the current is flowing in opposite directions in the segments AB and CD, the direction of the motion of the segments would be in opposite directions according to Fleming's step-down rule. When two ends of the coil experience force in opposite direction, they rotate. If the current flow is along the line ABCD, then the coil will rotate in a clockwise direction first and then in an anti-clockwise direction. If we want to make the coil rotate in any one direction, that is in clockwise direction, then the direction of the current should be along ABCD in the first half of the rotation and along DCBA in the second half of the rotation. And the gap in the splittering commutator is aligned with the terminals X and Y. There is no flow of current in the coil. But as the coil is moving, it continues to move forward, bringing one of the splittering commutators in contact with the carbon brushes X and Y. The reversing of the current is repeated at each half rotation, giving rise to a continuous rotation of the coil. Second question. Explain two types of transformer. So one is step-up transformer and another one is step-down transformer. And it is rotated in the iron core, that is primary coil, 110 bar 120 volt, to the secondary coil 220 bar 240 volt. And in step-down transformer, primary coil 220 bar 220 volt to the secondary coil 110 bar 120 volt. Explanation. Step-up transformer. The transformer used to change a low alternating voltage to a high alternating voltage is called a step-up transformer, that is V of S greater than V of P. In a step-up transformer, the number of turns in the secondary coil is more than the number of turns in the primary coil, that is N of S greater than N of P. Step-down transformer. The transformer used to change a high alternating voltage to a low alternating voltage is called a step-down transformer, that is V of S less than V of P. In a step-down transformer, the number of turns in the secondary coil is less than the number of turns in the primary coil, that is N of S less than N of P. Draw any diagram of that is the question. Draw any diagram of an AC generator and explain its working. So case 1 and case 2. Diagram is given. In the first case 1 diagram, the coil rotates and the direction is from A, B, C, D to B1, and that is to B2 to B1. And in the case 2, the direction will reverse, that is from DCBA to B1, B2, then the coil rotates. Explanation. An alternating current generator, as shown in the diagram, consisting of a rotating rectangular coil ABCD called armature placed between the two poles of a permanent magnet. The two ends of this coil are connected to two slip rings S1 and S2. The inner sides of these rings are insulated. Two conducting stationary brushes B1 and B2 are kept separately on the rings S1 and S2 respectively. The two rings S1 and S2 are internally attached to an axle. The axle may be mechanically rotated from outside to rotate the coil inside the magnetic field. Outer ends of the two brushes are connected to the external circuit. When the coil is rotated, the magnetic flux linked with the coil changes. This change in magnetic flux will lead to generation of induced current. The direction of the induced current as given by Fleming's electron rule is along ABCD in the coil, and in the outer circuit it flows from B2 to B1. During the second half of rotation, the direction of current is along DCBA in the coil, and in the outer circuit it flows from B1 to B2. As the rotation of the coil continues, the induced current in the external circuit is changing its direction for every half a rotation of the coil. Thank you friends. If you have any doubt, feel free to contact with our social network. We will meet in the next video. Thank you all.